I'm Anil Kumar, and in this video, let us have a quiz. We'll actually consider how to get information about acceleration from graph of position function, right? That's what we will consider. So what I will do here is sketch a graph for you. You can pause the video, answer the question, right? That's how we'll learn about it. So let us say an object moves from point A, goes along a straight line. That straight line indicates it is at rest. When we know that time is along the independent axis and position is along the dependent axis. Okay, so this is the point A, and at till point B, position doesn't change. And then the object moves, let's say like this, and then it kind of moves kind of like this, and then goes kind of like this, let's say like this, okay, and then again like this and goes horizontal. Let's say we work till this place. Now what you have to discuss is at different intervals, which I'm marking here, what happens to the acceleration, right? So these are points where the acceleration may change, right? So what really happens at this particular point? Okay, we can A, G, and H. So that's the question for you. Now, here is how I will try to attempt and solve this. We are looking at the graph of the function position, right? So this is position. As you know, velocity is rate of change of position, right? Let's say that is velocity. And we are actually talking about acceleration, which is second derivative of position. Is it okay? No. Let us summarize what we have learned so that we can easily figure out where will the acceleration be, 0, positive or negative, correct? So let's consider when will acceleration be equal to 0. So for acceleration to be 0, it could be a horizontal line, it could be a line going like this, or a line going like this, right? So all these indicate constant velocity. So constant velocity means rate of change of velocity is, let's say dv dt, is 0, right? Horizontal, however, indicates velocity itself is 0. So acceleration will also be 0. Is it okay? Can you tell me any other position where acceleration will be 0? Remember second derivative test? That is kind of very important. So acceleration is also 0 when there is change in concavity. We call these as point of inflection. Is it okay? Point of inflection. So wherever there is change in concavity, that is, it could go from concave up to concave down, or from concave down to up, or it could be like from up to down. At this point here, it could be 0. So that is kind of important to understand. So there are three scenarios where acceleration can be 0, right? So these are your scenarios for acceleration to be 0. Now from concavity, let's get back to acceleration. So acceleration is greater than 0, or acceleration is less than 0 when? Greater than 0 when we have something like concave up. Do you understand? And less than 0 when we have something like concave down. Does make sense to you? So we call this as concave up, and this is concave down. Now that should help you to answer this question very easily, correct? So what I will do now is create a small table. Since acceleration could have 3 values, we are not interested in actual values. We just want to know positive or negative or 0, correct? So we'll have columns in which we'll just write what happens to acceleration, right? So acceleration could be, as we have decided here, acceleration could be equal to 0, acceleration could be greater than 0, acceleration could be less than 0. 3 possibilities. We'll only write the segments where it is whatever. So wherever you see straight lines, those are when acceleration is 0. So we can write AB. We can write BC. Okay, so we have BC. And we can also write GH. So I'm purposely writing GH in this particular block. Reason is these are straight lines where velocity is constant or 0. Now acceleration is also 0 at change in concavity, right? So you see it is concave up and down. So that is a point of inflection, right? So this is a point of inflection. Same is the case at F. So at these 2 points, let's say point D and at point F, where we have point of inflection, acceleration is going to be 0, right? That's very important to understand. Now, where is acceleration positive? Concave up, right? So we're looking at concave up. So that is C to D, right? So C to D, okay, it is concave up, and F to G, right? And F to G. So these are the 2 portions or intervals when the object is accelerating, concave up. How about DEF? It is concave down, where acceleration should be negative. So we'll write this as DEF. Let me write this as an arc. DEF, acceleration is down, correct? So that is how we could quickly get to the result. What happens to acceleration on this position time graph? Is that okay? Right. So I hope you understand this part. Now this is a review question for you. Question is, get the information about velocity. Discuss velocity. Okay, so I have already discussed acceleration. You discuss velocity for the given graph. That'll be interesting. Velocity, as you know, is rate of change of position. I hope that really helps. If you find it interesting, put a thumbs up, share my videos, and share your comments. Thank you, and all the best.